Hello there, welcome to the October 2020 applied paper. Here we're looking at question 2. Jerry is studying visibility for Camborne using the large dataset, June 1987. The table below contains 2 extracts from the large dataset. It shows the daily maximum relative humidity and the daily mean visibility. Given that the daily mean visibility is given to the nearest 100, write down the range of distances in meters that corresponds to the recorded value 0 for the daily mean visibility. Well, if it's measured to the nearest 100, then 0 must be effectively representing the number of meters 0 to 50 meters. So the unit on daily mean visibility is meters. So if it's measuring a distance of 0 to 50, then that will round to the nearest 100, which will then round it down to 0. If it clocked over to 51 meters, then that would be rounded up to the nearest 100, which would be 100 rather than down to 0. So it's 0 to 50 is the answer for part A. Moving on to part B, Jerry drew the following scatter diagram, Figure 2, and calculated some statistics using the June 1987 data for Camborne using the large dataset. Jerry defines an outlier as a value that is more than 1.5 times the interquartile range above Q3 or more than 1.5 times the interquartile range below Q1. Show that the point circled on the scatter diagram is an outlier for visibility. Okay, so the first thing we'll need to do then is it looks like this would be at 1.5 times the interquartile range above the Q3 value. So first would be to work out what Q3 is equal to. So that's going to be 1100 plus 1600, and that's going to be 2700. So that's Q3. So now what we want to do is to find an outlier. So an outlier will be defined as being, starting from Q3, being 1.5 lots of the interquartile range above Q3. So if we work that out, 2700 add 1.5 times 1600, and that gives us 5,100. So anything above 5,100 would be considered an outlier. And it looks like this point here, it looks like each of the boxes go up in 200s. And that's midway between the one box up and 2 boxes up. So 5,300 it looks like this data point. So 5,300 is greater than 5,100. So therefore it is an outlier. It is an outlier. Okay, so there we are, that's the answer to part B. Part C, interpret the correlation between the daily mean visibility and the daily maximum relative humidity. Well, the answer to this, to part C, is as maximum relative humidity increases, the daily mean visibility decreases, because it has negative correlation. Don't just write negative correlation, you have to describe it in terms of the context of this question, which is on the axes of each of these questions. So for each of these axes. So as maximum relative humidity increases, daily mean visibility decreases. And there we are, that's the answer to part C. Let's move on to part D now, so the final part for this question. Jerry drew the following scatter diagram in Figure 3 using June 1987 data for Camborne from the large dataset, but forgot to label the x-axis. Using your knowledge of the large dataset, suggest which variable in the x-axis the scatter diagram represents. Well, what we could have here, so it looks like there's positive correlation between this variable and daily mean visibility. So we need to think of something that will be positively correlated with visibility. So I suppose hours of sunshine, and this is where your knowledge of the large data set comes into use, because you'll know the different types of variables that are in our data set. So number of hours of sunshine will be the with the variable here, because sometimes you'll have no sunshine, which means it will be cloudy for the whole day, and sometimes it will be not cloudy, so therefore you'd expect to have more visibility when it's not cloudy, when you've got more sunshine around. So there we are, that's the answer for question 2, worth 5 marks in total. Let's move on to question 3.